Hey guys, this is Coach Brian. I'm bringing you your 2026 spring semester exam review. There's a lot to cover on this, a lot of different topics, a lot of different just skills that we've learned throughout the school year. So I'm going to jump right in with question number one. Question number one is about transformations regarding a trig function. So one thing I like to do when I am given an equation like this is go ahead and label as much as I can. So sine is my actual trig function. All right, and remember that tells you that you are going to be starting, if you are graphing this, you're going to be starting in the center. Okay, you're going to be starting in the center. And then the letter directly in front of that, or excuse me, the number directly in front of that is A, which is our amplitude. Okay, that's our amplitude. That means the distance from the center to the top line or the peak is going to be +5, whatever that center line is, and then down to the bottom line will be 5 less. How do you get that midline? You get that midline from your K value. It tells you how far up or down the graph has been shifted vertically. Since this one's been moved down 8, that means our center line would be -8, and then we would take away 5 more to be down at -13, and we'd add 5 to be at -3 for this particular graph. And then the other thing we want to look at is that the amplitude is positive, which means this graph starts by going up. All right, it starts by going up. And then the only other thing we need to look at is in the parentheses here, we have our H value. Now, inside the parentheses, this is where the signs do the opposite of what you would normally expect. So when I see minus pi/7, I would normally think, oh, that's going to shift to the left, but that actually moves my starting point, this starting point right here where the graph begins, it moves it to the right. pi/7. So just to recap those, we have a amplitude of 5. We have been shifted down 8. We've been shifted right pi/7. And I guess if you wanted to, you could also say because it's sine, it's going to start in the center. And because A is positive, it's going to start by going up. I guess if you just wanted to be very thorough with that one. All right, so that's question number one. Let's move to 2. We've got a sinusoidal graph. All right, remember, sinusoidal, it just means repetitive, smooth curve, okay? So sine and cosine graphs are sinusoidal. So how do we tell the difference? Well, we just use the references that they give us. They say here to use radians. Okay, so we're not using degrees, we're using radians. Write the equation, find the domain, range, and vertical distance. So I'm going to use my 2 dots here that were given to me as my start and my finish, if you will. So I'm going to use just this section as my period or my cycle. I'm going to treat it as one wave, okay? That's one wave right there. Now, this wave starts, my starting point is high. It starts high. Since it starts high, that means it has not been reflected and that it is a cosine graph. Cosine starts high or low. Sine always starts in the middle or the center, sine center. Now, vertical shift. Vertical shift is going to come from my midline. In this case, my midline is at +8, which means this graph has been shifted up 8. Amplitude is the distance from the midline to a peak, which goes from 8 to 18, or from the midline to a trough or valley, which goes from 8 to -2. So since it goes up 10 to get to a peak and down 10 to get to a trough, my amplitude is 10. Horizontal shift is going to deal with where the graph originates. So if we look at our starting point, this would normally start at 0. But instead of starting at 0, we have moved left. And how far left have we moved? Well, we're over here at negative 25 now. So we moved left 25. Period is how many degrees or how much time or how much distance one wave covers. So you're looking at your x-axis here. And the way I like to find the period is take the final point or I'll say the final x and minus the initial or beginning x, okay? Final x minus the initial x. So our final x value here is 15. And our beginning one, like we said, is negative 25. 15 minus negative 25 equals 40. So this wave has a period of 40. Excuse me. Now, lastly, the b value. The b value, since we're using radians, is going to be 2 pi over the period. That can be simplified to pi over 20. And now we have all of the pieces that we need to write our equation. So our equation for this particular wave is going to be f of x equals k, which is our vertical shift, so 8, plus or minus, this has not been reflected, so we're going to say plus our amplitude, which is 10, our trig function, which is cosine, then we're going to open our parentheses, we're going to put our b value, which is pi over 20, and then we're using radians, so we're going to use x, and we went left, so this is going to be x plus 25, and close our parentheses, and that is our equation for this particular wave. We also need to find the domain, the range, and the total vertical distance. The domain for all sine and cosine waves is all real numbers. So negative infinity to infinity. The range is going to be the y values that the wave includes. So looking at the y values, we go all the way from negative 2 up to positive 18. So since these are included in our wave, we would use brackets and we would say negative 2 to 18. Lastly, we want to say, what is that total vertical distance? If I go all the way from negative 2 to 18, what's that total distance? Another way you could say this is 2 times your amplitude. So 2 times 10 is 20. That's our total vertical distance. Excuse me. For question number 3, it says find the exact values of the following trig expressions. Draw and label the appropriate triangle. So you need to know your angles here, and all of these are in radians. So it's helpful to know, how to convert between radians and degrees. It's also helpful, the little trick we used this year was if you match your denominator. So what I mean by that is, like, if I start over here at 0 and I go straight across from it, that's pi. Well, what would pi be if it had a denominator of 6? It would just be 6 pi over 6. And so from there, you can kind of break down into, okay, if halfway has to be 3 pi over 6, and half of that, even though it's, it's kind of ugly, is 1.5 pi over 6. I'm trying to graph 1 pi over 6. So it lets you know that kind of this general area is going to be around here. Okay, this is about pi over 6. Now we're looking for the cosecant of this, so we need to go ahead and drop a line straight down, perpendicular to the x-axis. And again, the reason it's helpful to know your radians as degrees is because I can quickly say, oh, pi over 6 is 30, which means this triangle is a 30, 60, 90. And remembering your ratios of sides, the short side of a 30, 60, 90 is always 1/2. The side across from the 60 is always square root of 3 over 2. And then our R value for all of these, R value is always positive 1. So we have all of the sides here. And now we just need to find the correct ratio. Remember, cosecant is the inverse of sine, or excuse me, the reciprocal, not the inverse, the reciprocal of sine. Which means if I know sine equals y over r, then cosecant is just the reciprocal of that, r over y. So what I need to do is I need to go find my r, which is 1. I need to go find my y, which is 1/2, and that is almost simplified. It's technically dividing by a fraction, so I need to keep, change, flip, which would just flip my 1/2 down here, and it would be 1 times 2, which is 2. So the cosecant of pi over 6 is 2. Now let's try it for the secant of pi over 3. I'm just going to move a little quicker through these. If you're not sure what these angles are, it's best to review your unit circle. But pi over 3 is 60 degrees. So I'm going to go up here to about 60 and create my line. That's pi over 3. Okay, I'm going to drop my line straight down, perpendicular to the x. And I know that pi over 3 is 60, so that means this triangle is a 60, 30, 90. I know that r is always positive 1. The side across from 30 is 1/2, and the side across from 60 is square root of 3 over 2. I'm looking for the secant. Secant is the reciprocal of cosine. So what that means is cosine, which is x over r, the reciprocal of that is r over x. So I need to go find my r value, which is 1, and I'm going to divide it by x, which is 1/2. And if you look, that's the same fraction we just had for question number 1. And so 1 divided by 1/2 equals 2. The secant of pi over 3 is 2. Now, if you look at these two, all right, not trying to divert here too much, but if you look, the cosecants of 30 degrees and the secant of 60 are coangles, complementary angles. Okay, complementary angles. And so we just learned this a couple of lessons ago that these complementary angles, okay, are equal. 30 and 60, you see, complementary, they add up to 90. So anyway, that's why those two are equal. Now, tangent of pi over 4. Again, if you're not sure where to start, you do your 0, you do your 4 pi over 4. You're like, okay, it's a fourth of the way there. If this is 4 of them and I'm just looking for one of them, that's going to put you right down the middle of quadrant number 1, pi over 4. And if it's right down the middle, that's 45 degrees. You're going to drop your line straight down. If this is 45, that means the whole triangle is a 45, 45, 90. And that means the sides are equal. So this one's going to be square root 2 over 2. This one's going to be square root 2 over 2. and r is and always will be positive 1. Now, tangent equals y over x. Another way you could think about it is opposite over adjacent. Regardless, your opposite or your y is square root of 2 over 2, and your adjacent or your x is square root of 2 over 2. Now, you could flip this, or you could just say, hey, I have a number divided by itself. Anytime you have a number divided by itself, the answer is 1. The answer is always going to be 1. Moving on, we've got a couple more. Cosine of pi. Cosine of pi. Well, if you remember, pi is, sorry, that's an ugly arrow. Pi is 90 degrees. So right here, this is pi. Just kidding. Pi is 180. Sorry. Pi is 180. So that means we're going to be over here at pi, okay? We're going to be straight across. Now, we're looking for the cosine, and like we discussed earlier, cosine equals x over r. X over r. What we need to do here is we need to plot pi. How do we do that? Well, we would go from the origin, and we would go to the left 1. Now, here we are not able to make a triangle like we were on the earlier problems because it's just a flat line. So what we would do is we would get the coordinates of this point. It is at -1, 0. That's my x, that's my y. And then the length of this line, r, is still positive 1. Cosine is x over r. So take your x and put it over your r. -1 divided by 1 is -1. That's my final answer. Cotangent of pi over 4. Well, if you go look back at example C, we've already plotted pi over 4. It's right down the middle of quadrant 1. Since it's right down the middle, that means it is also 45 degrees. Helpful to know that. We're going to drop a line straight down. We're going to make that 90-degree angle there. And we can go ahead and label this as a 45, 45, 90. And since it's 45, 45, 90, that means my sides are equal. They are both square root of 2 over 2. Now, cotangent is the reciprocal of tangent. What that means is if we know the ratio for tangent, which we do, it's y over x, we can just flip it to x over y. Now, in this particular case, x and y are still the same, so this is still going to end up being square root of 2 over 2 divided by square root of 2 over 2. You still have a number divided by itself. Anytime you have a number divided by itself, the answer will be 1. And lastly, we have the sine of pi over 6. We've already plotted pi over 6. It's over here. Pi over 6, it's 30 degrees. If you're not sure how to quickly do these, think about this. This entire line is 180 degrees. What's a sixth of that? 1/6 of that is 30. So if you're not sure how to quickly find your radians, pi over 6, think, what's a sixth? What's a slice? 1/6 of 180 degrees. Well, 1/6 of that is 30, okay? If it's pi over 4, say, what's a fourth of 180? What's a fourth of 180? It's 45. Think about pi over 3. What's a third of 180? It's 60, okay? It's 60 degrees. So hopefully that helps you a little bit. We've got pi over 6 here. I'm going to draw a line straight down. I'm going to create this triangle that is a 30, 60, 90. And I'm looking specifically for sine. Sine is y over r. Well, I know r is positive 1. And in this case, y is my vertical side, and it's across from the 30. So the short side of a 30, 60, 90 is a half. So in this case, y over r is 1/2 over 1, which is just 1/2. So that is how you find your trig ratios when given the angle and asked to draw a right triangle. Just make sure all of these, except for D, were in quadrant number 1. Just be sure that if you're given any questions in another quadrant, that you remember in quadrant 1, x is positive and y is positive. When you go to quadrant 2, okay, you've now had to move left, which means your x is negative. Your y is still going to be, sorry, I messed that up. Your y is still going to be positive, though. When you go to quadrant 3, you've had to not only move left, which means you have a negative x, you also have to move down, which means you have a negative y. And lastly, when you're in quadrant 4, you've moved to the right, which is positive, but you had to move down, which is negative. The way you can remember this is all students take calculus. So all sine, cosine, and tangent are positive. Students, that's just sine and cosecant. Take, that's just tan and cotan. Calculus, that's just cosine and secant. Okay, those are what's positive in each quadrant. All right, that's page 1 of your review. I will get part 2 going in the next video. Thanks.